So this is the first question, and over here they are asking that which of the beams will rotate clockwise. So looking at P, so here the anti-clockwise moment is 4 multiplied by 2, that is 8 Newton meter, and the clockwise moment is 4 into 1, that is 1 Newton meter. So this beam is going to move anti-clockwise. So here this is anti-clockwise. Now looking at this one, here the anti-clockwise moment is 2 into 4. So 2 into 4, that is 8 Newton meter. And the clockwise moment is 2 into 5, that is 10 Newton meter. So this is surely going to move clockwise. And now the third one, for that the anti-clockwise moment is 1.5 into 2, that is 3 Newton meter. And this one is 1 into 4, that is 4 Newton meter. So therefore, definitely this is also going to move clockwise. So the answer is Q and R are going to move clockwise. Okay, so here we have the answer. Q and R are the one which are moving clockwise. Let's see the second question now. Okay, so having a look at this question, it says that the beam is kept in equilibrium. So that is mentioned over here. This is kept in equilibrium by a force, and a pivot is on this, so that is a fulcrum. Now, if you want to see what is a clockwise moment, which is caused by this particular force, so that will be 20 into 120. So that is 20 into 120. And the anti-clockwise one, which is caused by this force, that will be F times the distance from the axis to the point of application of force, and that whole thing comes to 80. So that means that is 80 into F, and it is equal because they are in equilibrium. So F will be 20 into 120 upon 80. So 20 goes 4s are, 4 goes 3s are. So therefore the value of F should be 30 Newton. So let's say which option is that. Okay, so here we have our option is this one, that is 30 Newton is the value of force F. Okay, moving on to question 3 now. Okay, so this is question 3. This is a plank which is lying on the ground, and there is a load kept over there, 120 Newton. And you can see that this plank weight is acting over here, and the plank is lifted up by applying a force of 65 Newton at its end. Now this plank which is on the ground will be lifted this way, okay, by an upward force. So therefore this acts like a pivot. Okay, so now this particular motion, okay, which is anti-clockwise, will be balanced by the weight and the 120 Newton. Okay, so that's what we are going to equate. So let me write down this particular motion, okay, that is anti-clockwise. So that will be 65 into this distance. Now this is a pivot, so this will be 0.5, then 1.5, that will make it 2 meters, and another 2 meters, so that will be 4. Okay, now this is countered by the clockwise motion, and clockwise motion is this 120. So 120, and the pivot and that distance is 0.5. And we will also add this W over here, and this distance from the pivot to W, that will be 0.5, and 1.5, that will be 2. Okay, so I'll just erase this so you have a clear view of this picture. Okay, so now what we have is 60 plus 2W is equal to 65 into 4, and that will be 260. Okay, so 2W will be 200, and therefore W will take the value of 100 newtons. So which is that option? It is option number 3, that is 100 newtons. Okay, now moving on to question 4. Okay, so this is question 4, a question similar to the previous one. It is given that the beam is in equilibrium. So therefore we identify the force that is turning it anti-clockwise, okay, and the force that is turning it clockwise. So the clockwise motion, this case, is due to the weight of the beam, and that is what we have to find out over here. So let's call that as W, and this is a pivot. So that distance is equal to 5 centimeters, as you can see, 2 and 3. So therefore I will take W into 5, and that is countered by this motion, which will be clockwise motion, and that will be 5 multiplied by 2. Okay, because the distance from the pivot is 2. So therefore W will be 5, and this 5 goes down, cancels. So W will be 2 Newton. Okay, let's see which option matches with our answer. Yes, so we have the first option, that is 2 Newton over here, matching with our calculation. Okay, moving on to the next question, question number 5. Okay, question number 5 now. Now this question is a very interesting question. First of all, they have said that the pivot is at the midpoint. So this distances are equal. And for it to remain balanced, that means the force downward over here should be equal to the force downward over here. Now this force on the left hand side is 1 Newton. That means this force should also be 1 Newton. Now the thing is, pan weighs 0.2 Newton. So this pan weighs 2 Newtons, and we have to add weights each of 0.1 Newton over here. So if we add one weight, so that will become 0.2 for the pan and 0.1. So that will make it 0.3. So the question that they have asked is how many such weights you will add. Now this is obvious that you will add 8 of such weights. So that will make this particular calculation as follows. So this will be 0.2 and 0.8. So that will make it 1. Okay, so then it will be able to balance this 1 Newton. So the answer to the question is 8 0.1 Newton weights will be should be added, so that this also weighs 1 Newton, and the rod becomes balanced. Okay, so let's move to the next question. Okay, so over here now, it's also a very good question. They are asking that which diagram shows the rod in equilibrium. Okay, so you can see that this is pivoted at the center, they are saying, in all the diagrams. So here 100 Newton is pulling it anti-clockwise, and this 100 Newton is pulling it clockwise, and therefore the torque should balance. So that means the anti-clockwise moment should balance the clockwise moment, and therefore according to me A should be the one which is in equilibrium. Let's see about the others. Now since both the forces are in the same direction, okay, now if it is not attached to the pivot, if it is just resting on the pivot, then probably there are chances that this rod should just go ahead, translation motion to the rod. Okay, and talking of C, of course now you must have figured out that both of them are clockwise, and therefore this particular rod is going to turn clockwise. It will not be in equilibrium, it is going to experience rotation. What about D? Now this is interesting. There is 100 down and 100 up, so they are going to cancel each other. So the only force left is this 100 Newton downward, and that is going to make this particular rod turn clockwise. So that is also not in equilibrium. So the answer is A. A is the diagram which shows equilibrium. Okay, so let's check the answer. Okay, so here is the answer. That is A. A is in equilibrium. Okay, let's go to the next question. Now, this is also an interesting question. They are asking that which diagram shows the lamina in equilibrium. So now over here, the way the lamina is, remember always, this is the center of gravity. The weight will act straight down everywhere. Okay. So here the weight will be straight down. Here also it will be straight down like this. So now this is very clear that since the weight is acting downward, but the support is only over here, so therefore this is not going to stay the way it is. It should be falling like this. Okay. Now this is a balanced one because its weight is straight down. So over here, this particular weight, you can see that this is straight downward over here. Okay, so this is the center of gravity, and that center of gravity is acting straight down, and it is being supported also. But let's talk about the next. Here also you can see that this arrow is pointing down, but it is supported at this particular point. So this is going to fall over here. This also, the center of gravity is along this line, which is not where it is supported. So this is also going to fall. So my answer is B. B is the point where the lamina will be in equilibrium. Okay, let's check which option is that. Okay, so this is the answer B. Now let's check the next question. Okay, so here is another question for us. So, and the question is, where is the turning effect greatest? So now, again, as you can see that this particular force, and this is the pivot here. So this is turning it this way, and this force is turning it that way, and they are assisting each other, and therefore this is going to rotate. Also taking into consideration the distance is at the very far end of this rod. Now let's talk about this force. Here also both these forces are assisting the motion, and the motion is this way, like it is going to turn that way. But this is lesser than A because the second force, the distance is less. Okay. So if we have to give values just to show you how much it will be. So let us say that this particular force is 5 Newton. This is 5 Newton. And let us say that this distance is 10 and this is also 10. So that means it is going to be 5 into 10, that is 50. And the other one is also 50. So I'm writing over here for A, it is 100 Newton meter. Okay. Now let's see what happens for B. So this is again 5 and that is 10. This is 5, but that's not 10. So that should be taken as half of it, that is 5. So what do you get? 5 into 10 plus 5 into 5. So that will be 75. So B is giving us 75 Newton meter. What about C? Okay, now C, this force is turning it in one sense, and that is 5 into 5. Let's take that this is midway. Okay, so that is 25 Newton meter. And this force is also 5 into 5, 25, but that's turning in the opposite sense. So therefore, in fact, they are going to cancel each other, 25 minus 25, and that is going to be 0. Now the same thing is going to happen for D. This is 5 into 10, 50 is going to turn it in this sense, and 5 into 10, 50 is going to turn it in the opposite sense. So D will be 50 minus 50, that is 0. So here is our answer, that A is going to have the greatest turning effect. And if you want to write an answer without any values, you have to say that the forces are assisting and the forces are far from the pivot. So therefore, they will create a greater turning effect. So here is our answer, and that answer is A. Okay, let's move to the next question. Okay, now for a triangular lamina, you know that the center of gravity is at the meeting point of the medians. So if you take this arrow over here, right from this vertex, so that goes there. If you take it another from here, from this vertex, that goes down, and then the third one will be from the other vertex, and that goes here, and that's the answer in front of you. C is the answer, okay? Because these are the medians, and the medians are meeting at a point C. So the answer is over here, that is C, which point is the center of mass. Okay, let's move to the next question. Okay, so here the passengers are not allowed to stand on the upper deck. Now, upper deck is this one. Okay, so this is the lower deck. Now, this is to do with the center of gravity, because as the bus is empty, the center of gravity is here near the chassis where the engine is. And as people start filling in, they first ask to fill the lower deck, and thus the center of gravity starts shifting up. Okay, so if people who are seated over here, they start standing up, then the center of gravity will shift further up, and that is going to make the bus less stable. Okay, so there are chances of the bus toppling down in case if it goes on an uneven surface. Okay, as long as it is running on a flat road, that's fine. But while taking turns on an uneven surface, if it becomes imbalanced, then there are chances of the bus toppling down. And that is the reason why I choose this option, that would make the bus less stable. Okay, slowing down has no logic to it. Kinetic energy also depends on the mass. So if the people are standing or seated, the mass will remain the same. But as we have studied, the distribution of mass will change the position of center of gravity. Okay, let's go on to the next question. Okay, so this is question 11. And as the question has very clearly shown, this is a pivot and there are three forces acting. Okay, and they're asking that what is the effect of these forces. So first of all, let us talk about this 100 Newton over here. Now this 100 Newton is pushing the pivot, the direction of it is such that it is pushing the pivot. So this is not going to cause any rotational effect. Okay, so like this is your door and the handle. So you either pull it or you either push it. So if you try to apply a force on the door like this, that's not going to happen. Okay, nothing's going to change. The door is not going to go inside the wall like this. Okay, unless that is a sliding kind of a door where you're pushing it like this. Okay, and that is the reason why when you have to define rotational motion, it says that the body needs to be pivoted and a force need to be applied at a suitable place. Okay, so that suitable is, this is not suitable. Yeah. Now, these are the two forces obviously are going to cause rotational, and they are equal. But the fact you can see very visibly that they are not at the same point. Their line of action is not the same. And that is the reason why the torque is not going to get cancelled. Okay, and also it is very visible over here that the anti-clockwise torque that is caused by this is greater because it has a greater perpendicular distance. So according to me, this handle is going to turn this way. and that is because of this 100 Newton force. Okay, so let's see what are the options. Okay, so the option is the handle is going to move anti-clockwise, and that is it is going to turn to the left. Okay, so now the next question. Okay, so another question, question number 12. It says that this beam is in equilibrium. So the meaning of equilibrium, that means the clockwise should be equal to the anti-clockwise. Okay, and over here, this distance is very obviously, if I write it as d1 and d2, so we know that d1 and d2 are not equal. And let's say that the baby's weight, we call it as b. So b into d1 is going to cause anti-clockwise torque, and w into d2 is going to cause a clockwise torque. Now, since these distances are unequal, that means the shorter distance should be having a greater weight because the torques are equal. Okay, so that's very clearly indicates that this baby weighs less than w. Okay, so which option do we choose? The what is the weight of the baby? Less than w. Okay. Okay, so these questions should be easy. When force acts on a body which is rigid, which is stationary and free to move, then the body performs translation motion. Now here I would like to make a point that if the body is not rigid, then force applied on the body will deform the body. Okay, an example is clay. So clay is an example where the body is not rigid and force is applied on it. So it can move, but it will also get deformed. Okay, now in question 14, force, I'll take Newton. Moment of force is Newton meter, and the perpendicular distance should be meter. Clockwise, I'll choose negative, and anti-clockwise, I'll choose positive. Let's check the next questions. Okay, so what we have is question 15. The position of center of gravity for a uniform rod is the geometric center, and the position of center of gravity for a circular disc is also the geometric center. Okay, so however, the center of gravity for the uniform rod, a better option would be its midpoint, the midpoint of the axis.